Hey everyone, ready for another deep dive?
Always. Yeah.
Okay, cool. So today, we're going to be talking about AI
Okay.
and code optimization.
Right.
Specifically, can AI write better code than humans?
Now, that is a question that's on a lot of people's minds.
Yeah, I mean, this is really the future that we're all kind of thinking about, like,
Right. It's the one keeping us up at night.
exactly. And our guide for this deep dive is going to be a blog post
Okay.
by Max Wolf. He's a senior data scientist over at BuzzFeed.
Interesting.
And he decided to just go ahead and ask this question
Okay.
using Claude 3.5 Sonnet.
Using an LLM. That's interesting. So what did he find?
Yeah, so he basically asked Claude, can you write better code?
Really? Just straight up.
Yeah, pretty
Right.
much. And I mean, it's a great question because even these LLMs,
Right.
they're trained on just massive amounts of data,
Hundreds a day.
including code.
Right.
So they start to recognize these patterns and structures.
Sure, that's right. Yeah.
And then when you ask them to improve on something, they can kind of draw on this vast knowledge
That's
to
it.
come up with.
Like having a super brain.
Yes. It's
Yeah,
like
oh.
having access to like the collective wisdom of programmers
Yeah.
throughout history.
Thousands of programmers all in one little package.
Exactly. So it's a really fascinating experiment.
So tell me about this experiment. What did he do?
Okay, so Max actually had two different experiments.
Oh, okay.
The first one he calls casual prompting.
Casual prompting. So just
Yeah.
kind of like a normal developer workflow.
Exactly, yeah. So it's like you write some code,
Uh-huh.
realize it could be better, and then you go back to the AI and you're like, hey, can you
Didn't fix this.
can you improve this?
Okay.
So for this first test, Max gave Claude a pretty specific challenge.
Okay, what was it?
Find the difference between the smallest and largest numbers in a list of 1,000,000 random integers where the digits of each number add up to 30.
Whoa. Okay, so this is a real challenge.
Yeah, this is not like a beginner coding problem.
And this is not like a code challenge problem either. Like he didn't just pull this from the internet
No. This was something that he specifically designed.
to see how the LLM would do.
Yeah, and it was interesting because, Claude's first attempt at the code it worked,
Okay.
but it was definitely,
It was functional,
yeah, it was functional.
but not elegant.
Yeah, it was like a first draft.
Yeah.
Like the ideas are there,
Yes,
but
sir.
it definitely needs some refining.
So very novice.
Very novice, yes. But then
Okay.
Max hit Claude with those magic words. Write better code.
Ooh, I love it.
Yeah.
And what happened?
And this is where it gets really interesting because with each iteration,
Yeah.
Claude came up with these increasingly sophisticated optimizations.
Right.
We're talking things like pre-computing digit sums,
Oh, wow.
switching to vectorized operations,
Right.
like stuff that real programmers use to make their code faster.
Yeah, so these are not just trivial things. This is like,
No, these are legit.
the
Yeah.
real deal.
And it's like you're watching this AI
Yeah.
learn in real time.
Right, and apply it.
And it's like, wow, even someone with coding experience could probably learn a thing or two from watching this.
That is so cool.
Yeah, it is.
So it's almost like this AI is teaching us
Right.
new tricks
Yeah.
that we might not have thought of.
Exactly.
Wow. So
Yeah.
what happened next?
Okay, so as Claude kept going with these optimizations,
Mm-hmm.
the code got pretty complex.
Okay.
Like Max describes it as going cosmic.
Going cosmic. What does that even mean?
So it went from this straightforward solution
Okay.
to something you might see in like a massive enterprise level system.
Really?
Yeah, it started adding things like Prometheus logging
Whoa.
and signal handling.
Okay, so it's like it went from building a bicycle to like constructing a spaceship.
Yeah, but here's the thing.
Okay.
It still worked.
Right.
The code still worked perfectly.
Wow, that's impressive.
It just became this really complex
It's kind of
beast of a program.
so it's raising this question of what do we really mean by better code, right?
Exactly, yeah. Is it purely about speed
Yeah.
or is it about readability, maintainability?
Obvious things. Yeah.
Because, I mean, the code was definitely faster.
It was faster.
Like, we're talking 100 times faster.
Wow, that's incredible.
But it got to that point in a way that's like,
yeah,
shows we still need,
some oversight.
yeah, we need to guide these AI systems.
We need to be sure that, the AI's definition of better and our definition of better are actually the same.
Exactly, yeah. So it's a partnership,
Right.
not a replacement.
Interesting. Okay. So that was the casual prompting.
That was casual prompting.
And he had a second experiment, right?
He did. This one involves something called prompt engineering. And that's a whole other story.
Oh, okay. Well, I can't wait to hear about it.
Yeah, so stay tuned. We'll be right back to unpack all that in part 2.
All right, so we're back. And we just saw how Claude, took this coding challenge and with a little nudge, write better code, made it like 100 times faster.
Right, which is incredible.
Yeah, seriously. But it sounds like there's even more to this story.
There is, yeah. So in his second experiment, Max decided to use a technique called prompt engineering.
Okay, prompt engineering.
Yeah.
So instead of just saying write better code, which is kind of vague,
Very vague.
yeah, you give the AI like really clear instructions and examples of what you're looking for. It's
Exactly.
like the difference between asking someone to make dinner and giving them a really detailed recipe.
Her recipe, yeah. I like that analogy.
Okay, cool. So how did Max apply this prompt engineering magic?
Well, he started with what's called a system prompt.
System prompt.
It's like you're setting the ground rules right from the start.
Okay, so it's like before Claude even writes any code,
Right,
you're
exactly.
telling it what the rules of the game
Yeah,
are.
exactly.
And in this case, Max was very specific.
Like what kind of things did he say?
Well, he specified that the code must be fully optimized.
Okay, so no more of that going cosmic stuff.
No cosmic code this time.
Gotta stay grounded.
Yeah, keep it simple. And he even listed out criteria for what that meant.
Oh, wow. So like a checklist.
Kinda, yeah. Things like maximizing efficiency,
Okay.
using techniques like parallelization and vectorization,
I see.
and just, generally adhering to good coding conventions.
So he was really laying down the law.
Yeah, he was being very specific.
Did he also threaten to take away Claude's internet privileges if it messed up?
Well, not exactly. But he did add a little bit of playfulness to the prompt.
Okay.
He told Claude it would be find $100 for any code that wasn't fully optimized.
I love that. It's like he gamified the whole optimization process.
Exactly.
So did this tough love approach actually work?
It did. In
Yeah.
fact, just using this more structured prompt, Claude's initial code was already 59 times faster than its original attempt in the first experiment.
What? So just by being super clear about what he wanted, Max was able to get this incredibly efficient code right off the bat.
That's right.
That's crazy.
Yeah.
Okay, so what happened next?
Well, with each iteration, Max continued to find Claude for any shortcomings.
Keeping the pressure on.
Yeah, exactly. And this led Claude to explore some really interesting techniques.
Like what? Did it start writing?
Claude started experimenting with things like bit manipulation and SIMD operations.
Okay, bit manipulation sounds kind of intimidating.
It can be, yeah.
Yeah.
It's a way of working directly with the individual bits that make up data.
So like getting down to the nitty-gritty,
Right, yeah.
really low
But
level.
really low level, yeah.
So pretty impressive that Claude was able to figure that out.
It is impressive.
And what about SIMD operations? What are those?
SIMD stands for single instruction, multiple data. It's a way of processing multiple pieces of data simultaneously.
Wow, so it's like a super-powered calculator that can do many calculations at the same time.
Exactly.
Okay, so Claude was really pulling out all the stops. But with all this advanced optimization, did it manage to avoid that over-engineering tendency we saw in the first experiment?
Yeah, for the most part. The code was definitely more concise this time around, but there were still a few hiccups.
Uh-oh, what happened? Did it try to rewrite the laws of physics again?
Not quite, but there were a few instances where Claude's optimizations actually introduced bugs or inefficiencies. For example, at one point it tried to use bit manipulation for decimal numbers.
Which doesn't really work, right?
It doesn't really work the way it intended, no.
So even with this fancy prompt engineering,
Yeah.
Claude still needed a human to come in and, like, fix those little errors.
Exactly. And this is a really important takeaway from all of this. These systems are super powerful,
Yeah.
but they're not replacing human programmers.
Right. It's still a team effort. But even with those bumps in the road, it sounds like Claude achieved some pretty mind-blowing results in this second experiment.
It did.
What was the final verdict on its performance?
Well, with those carefully crafted prompts and a little bit of human debugging along the way,
Okay.
Claude was once again able to achieve that 100x speed improvement
Wow.
and with significantly less code than the first experiment.
So 100 times faster
Yeah.
and with leaner code.
That's right.
That's amazing. Okay, so what does this mean for the future of coding? Are we all about to be replaced by AI overlords who write perfect code in their sleep?
I think the reality is far more nuanced and frankly even more exciting than that.
Ooh, a cliffhanger. You've definitely got my attention.
All right, well, stay tuned because in part 3 we'll unpack all of that and explore what this all means for the future of coding.
All right, so we're back for the final part of our deep dive into AI and code optimization. We saw Claude, that LLM, get some pretty incredible speed improvements, just like 100 times faster in both experiments. But what else did we learn from all of this? Like, is it just about speed or is there something deeper here?
Yeah, you've hit on a really important point. One of the things that Max found was that even with those impressive gains, Claude actually missed some potentially big optimization.
Wait, really? But we were just talking about how it got like 100 times faster. What more could it have possibly done?
Well, remember, the whole challenge was about, finding these specific numbers within this massive
Mm.
list of random integers.
Yeah.
Well, it turns out that Claude never actually considered, like, deduping the list,
Hmm.
removing all the duplicate numbers.
Oh, I see what you mean. Yeah,
Uh,
if you've got a bunch of duplicates, you're basically doing all this extra work for no reason.
Exactly. And this really highlights, like, a fundamental difference between how LLMs and humans approach, problem solving. LLMs are amazing at recognizing patterns and applying these learned optimizations, but they can sometimes miss, like, the bigger picture,
Yeah.
the kind of contextual understanding that we as humans bring to the table.
Yeah. So it's like having this crazy fast calculator that can crunch numbers like nobody's business.
Right.
But it doesn't necessarily know like why it's doing those calculations.
Exactly.
Or if there might be like a simpler way to approach the whole problem.
That's a great analogy. And there was something else interesting, too. Claude never even tried to sort the list of numbers before it started analyzing it.
Oh, interesting. Well, wouldn't sorting the list make it a lot easier to find those smallest and largest numbers? You know, the ones with that specific digit sum?
It certainly could, but
Yeah.
sorting itself can actually be pretty computationally expensive.
Oh, okay.
And Claude, laser focused on speed as it was,
Yeah.
probably figured that sorting would actually be less efficient than the approaches it was already using.
So it's a trade-off.
Exactly.
Like different strategies have different strengths and weaknesses. And that's where, I guess, human intuition and understanding of the problem really come into play.
Absolutely.
Yeah. We can weigh those trade-offs, think about things that an LLM might not even consider,
Uh-huh.
and make sure that the optimization process is actually aligned with what we're trying to achieve.
Exactly.
Okay, so even with those missed opportunities, Claude's achievements are still pretty impressive. Like, it's definitely showing us what LLMs can do in this area.
Absolutely. And I think beyond just the performance gains, there's another really valuable lesson here.
Okay.
Even when LLMs produce code that's not, perfect or immediately usable, they can still spark all these new ideas
Yeah.
and offer valuable insights.
Yeah, like how Claude kind of introduced Max to that Numba library.
Exactly. So Max, as a data scientist, was already familiar with NumPy. That's a library that's used for optimizing these numerical computations.
Right.
But when Claude started using Numba, Numba's a library that can compile Python code and make it run even faster.
Okay.
It opened up this whole new avenue for Max to explore.
So even though Claude wasn't perfect, it still managed to push a human expert in a new direction. Like, it made him think about tools and techniques that he might not have even considered otherwise.
Right, which is incredible when you think about it.
Yeah, that is pretty cool. So what's the takeaway here? Like, are we all going to have AI coding weddies in the future helping us write, super efficient code while we kick back and relax?
Well, I think that future is probably closer than we realize.
Okay.
The key, as Max points out, is to approach these LLMs not as replacements,
Okay.
but as collaborators.
Collaborators. So we're going to be doing code reviews with AI bots over Zoom.
Well, maybe not Zoom specifically, but yeah, the idea of actually collaborating with AI on code is becoming more and more real.
Interesting.
Imagine, in the future, you could bounce ideas off an LLM,
Yeah.
get instant feedback on your code,
Okay.
and really leverage its optimization superpowers to create software that's faster, more efficient,
Okay.
and just more powerful than anything we could do on our own.
Okay, that sounds really exciting and maybe a little bit intimidating, if I'm being honest. Like, what if the AI starts judging my code and tells me I'm doing everything wrong?
Well, that's where the beauty of collaboration comes in. We, as humans, are still in the driver's seat. We define the goals, set the boundaries, and ultimately decide which optimizations actually make sense. LLMs are tools, incredibly powerful tools,
Yeah.
but still tools nonetheless.
Okay, that makes me feel a lot better. It sounds like we're really entering a new era of coding, where human creativity and AI come together.
And I think that's really the most important point here. The future of coding isn't about humans versus machines. It's about combining the best of both worlds to unlock possibilities that we can only dream of right now.
I don't know about you, but I'm feeling pretty inspired. If you want to learn more about this, definitely check out Max's full blog post and the code examples. They're on GitHub. And hey, Maybe you'll even find some optimizations that Claude missed. Until next time, stay curious and keep exploring the world of tech.